Good day, everyone. This is Teacher Kathy, and this time we're going to discuss solution to the exercises in Lecture 6. There were two numbers posted as exercise in Lecture 6. The first number is to solve the system of three equations in three variables given by x plus y plus z is equal to 2, y minus 3z is equal to 1, 2x plus y plus 5z is equal to 0. It was posted that there is no solution for this set of three equations. Now for number 2, we are asked to solve the following system. That is, x plus y plus z is equal to 7, 3x minus 2y minus z is equal to 4, and x plus 6y plus 5z is equal to 24. And it was also posted that the answer is that there is an infinite number of solutions of the form x, 4x minus 11, negative 5x plus 18. So here's the solution for number 1. We have the following steps and solution. So choose two different pairs of equations and eliminate the same variable for both pairs. And this will reduce the system to two equations and two unknowns. Before that, let us name the given equations or denote the equations as e sub 1, e sub 2, and e sub 3 with the following. E sub 1 is x plus y plus z is equal to 2. E sub 2 is y minus 3z, and our e sub 3 is 2x plus y plus 5z is equal to 2. And then note that our goal is to reduce the given system in two variables. Notice that we can eliminate x by multiplying equation e sub 1 with negative 2 and adding e to equation 3. Then we denote the resulting equation as e sub 4. So we have it here. We have multiplying e sub 1 by negative 2. This is our e sub 1. So you come up with minus 2x minus 2y minus 2z. 2 minus 2 is negative 4. And then adding it to equation e sub 3. E sub 3 is 2x plus y plus 5z is equal to 2. We have 2x plus y plus 5z equals 2. When we add negative 2x with 2x, that's 0. Negative 2y with y is negative y. Negative 2z plus 5z is plus 3z. And negative 4 plus 2 is negative 2. So our new equation now is e sub 4 negative y plus 3z equals negative 2. Then the next step would be as follows. Add equation e4 to equation e2. So since our e4 here is negative y plus 3z equals negative 2, and e2 is y minus 3z equals 1, we have the following. That is, negative y plus y is 0, and plus 3z minus 3z is 0. Negative 2 plus 1 is negative 1. So we have 0 is equal to negative 1. And what does it mean? The final equation, 0 equals negative 1, is a contradiction. So we conclude that the system of equations is inconsistent and therefore has no solution. And as for analysis, we have in this system, its plane intersects the other two but not at the same location. Therefore, the system is inconsistent. Graphically, we have the following. So if you take a look at the graph here, we have equation x plus y plus z is equal to 2 is this violet graph here. Equation 2, y minus 3z equals 1 is the pink graph here. And equation 3, 2x plus y plus 5z is equal to 0 is the green graph here. Notice that in this system, its plane intersects the other two, so these two, but not at the same location. Therefore, it has no solution. Our next problem is to find the solution to the given system of the equations in three variables. X plus y plus z is equal to 7, 3x minus 2y minus z is equal to 4, and x plus 6y plus 5z is equal to 24. So for our solution, the following steps. The first one is to choose two different pairs of equations and eliminate the same variable for both pairs. This will reduce the system to two equations and two unknowns. So first, let us denote the equations by e sub 1, e sub 2, and e sub 3. So we let our e sub 1 be x plus y plus z is equal to 7, e sub 2 be 3x minus 2y minus z is equal to 4, and e sub 3 be x plus 6y plus 5z is equal to 24. And then eliminate z by adding equation e sub 1 to equation e sub 2 and denote the resulting equation as e sub 4. So we have e sub 1 is x plus y plus z is equal to 7. And then we add it with 3x minus 2y minus z. So x plus 3x here is 4x. Y minus 2y is negative y. Z minus z is equal to 0. So we're able to eliminate z. So we have 7 plus 4 equals 11. And then we eliminate again z by multiplying 5 to equation e sub 2 and adding it to equation e sub 3. So since our e sub 2 is 3x minus 2y minus z equals 4, when we multiply it by 5, we have now 15x. Then we have minus 2y times 5 will give us negative 10y, negative z. Multiplied by 5 is negative 5z. 5 times 4 is 20 here. And then add it to equation e sub 3. So 15x plus x is 16x minus 10y plus 6y is negative 4y. And we're able again to eliminate c here. And we have 20 plus 24 is equal to 44. Now we continue solving in finding the solution to the given system of three equations in three variables. X plus y plus z is equal to 7, 3x minus 2y minus z is equal to 4, x plus 6y plus 5z is equal to 24. So here are the steps. We have here, we next multiply equation e sub 4 by negative 4 and add it to equation e sub 5. Negative 4 times e sub 4 will give us negative 16x plus 4y equals negative 44. And since e sub 5, as computed earlier, is 16x minus 4y equals 44, adding them will give us 0 is equal to 0. Now what does it mean? We do not need to proceed any further. The result we get is an identity 0 equal to 0, which tells us that this system has an infinite number of solutions. Now, in finding the solution to a dependent system of equations, there are other ways to begin to solve the system and find the same result, 0 is equal to 0. So, when a system is dependent, we can find general expressions for the solutions. And adding equations e sub 1 and e sub 2, we have the following. Yes, since e sub 1 is x plus y plus z is equal to 7, and e sub 2 is 3x minus 2y minus z is equal to 4, when we add them, x plus 3x is 4x, y minus 2y is negative y, and z minus z is 0. So we have 7 plus 4 is equal to 11. Solving for y, we have 4x minus 11 is equal to 4x minus y is equal to 11, so that we now have the following. That is, y equals, we have 4x minus, this time, 11. So for the continuation, we back substitute for y equals 4x minus 11 into one of the equations and solve for z. So since our e sub 1 is given by x plus y plus z is equal to 7, Then we can now substitute y equals 4x minus 11 into y here. So we have x plus 4x minus 11 plus z equals 7. But x plus 4x will give us 5x. We have minus 11 here, and then plus z is equal to 7. So simplifying further, we have the following. We have 5x minus 11 plus z is equal to 7. And that would be z is now equal to 7 minus 5x plus 11. But z equals 7 minus 5x plus 11 will give us z equals negative 5x plus 18. So we have this, meaning to say the general solution is given by x, then our y is 4x minus 11, and z is negative 5x plus 18. So in this solution, x can be any real number, and the values of y and z are dependent on the value selected for x. So here's the sketch. For equation 1, we have the green one plane here, and then equation 2, the violet plane here, and equation 3 is the pink plane here. Notice that the solution set is infinite as all points along the intersection line, the intersection line, will satisfy all three equations.